I think it's really important before you start your division to go ahead and do multiples of whatever divisor you're using. So for example, I made a table of multiples for 8, all the way up through 8 times 7. Step 1 of my division problem, I have labeled the problem, which we have 4,962 divided by 8, and I have labeled it in the long division box with 4,962 as the dividend, 8 as the divisor, and a quotient which is unknown. For step 2, we see how many times 8 goes into 4. As we know, 8 goes into 4 0 times. So you subtract 0 from 4 and you get 4. And you put a 0 above the 4 to hold the place value. For step 3, you bring down the 9. So for step 4, you've brought down the 9 and you're seeing how many times 8 can go into 49. If you refer back to the multiplication table, we know that 8 goes into 49 6 times. 8 times 6 is 48, so you subtract 48 from 49 and you get 1. For step 5, you're bringing down the 6 to come next to the 1. In step 6, we've brought down the 6 next to the 1. Now we're trying to see how many times 8 goes into 16. It's easy to know that 8 goes into 16 2 times, so you put a 2 up next to the 6 in the quotient area, and you subtract 16 from 16, giving you 0. For step 7, we have brought down the 2. We all know that 8 goes into 2 0 times, so you subtract 0 from 2, giving you 2, which is the remainder. Your final product, or quotient, is 620 remainder 2. The rule for division is as follows. A divided by B equals C. Therefore, C times B equals A. Using this rule, you can check your work and see why exactly we need a remainder when doing long division. To check your work, you take the original quotient without the remainder, in our case 620, and you multiply it by the divisor. If you take 620 and multiply it by 8, you get 4,960, which is not our original dividend. If you add the remainder, though, you will get our original dividend of 4,962.